Hello everyone and welcome back to Kilohertz. In this video I will be reviewing the LDR or the light dependent resistors. This is how they look like. These two are LDRs, also known as photoresistors or as photocells as well. Well known as photoresistors, but less known as photocells. That's how they look like. Normally there is the ceramic layer in here, and usually in height they are somewhat around 2 millimeters to 2.2 millimeters, and as for the width itself is somewhere around 5 millimeters. And as you notice in here, not all of them are created equally. Some have more squiggly lines than others. Like this one is a little bit darker as well. And in between those two leads in here, they lead to electrodes, and in between them you find some photoconductive material known as cadmium sulfide. And as per the data sheet, they say they are suitable to work between minus 30 degrees centigrade to plus 70 degrees centigrade, which is a very good range, and they can go up to 150 volt, well, DC. However, I've never tried them at 150 DC so far, but they function fine at 5 volts when using them with the Arduino, as you can see in here. What else? The transparent layer in here, there's a transparent layer on top to cover, I believe, to protect them. And these are the kind of resistors, or what we call them as variable resistor. They come in the hobby kits that we buy from your local store and from online stores as well. And as a hobbyist, you can use the LDRs in projects such as were required to turn on, turn off devices based on lights. And for example, it's like a night light that you want to activate. So in a sketch, or in, let me zoom in actually, in a circuit, the symbol for the photoresistor is a rectangle, just like a resistor normally, with 2 arrows going in, or you can actually draw a regular resistor with 2 arrows going inside them and as well. As you can see in here, let me zoom back out a little bit. I have a circuit already done, and the light is on because there's not enough light going into the resistor, because that's how I programmed the Arduino to turn the light on when it reaches 300. I guess it's less than 300, or actually more than 300 right now, but if I shine light onto it, it turns off. Put the light back on. So as you can see, you can turn on and turn off devices based on the sketch that you write. And this circuit that I have in here, I'm just going to draw it fast. Probably I'm going to put a Fritzig diagram as well for it. Let's say this is the Arduino. Alright, and we have the A0 where I have the resistor connected to, the photoresistor, and this is the pin 13 where the LED is on. This is the 5 volts, and this is the ground. So the photoresistor is right here, connected to 10 mega ohm resistor, and going to A0 as well. And the other lead is going to the ground, which is common with the LED, which I have right here, connected to another resistor that's a 220 ohm resistor going to pin 13, and the ground is being shared with both. That's pretty much it, and the sketch I'll get into it later on with a different video. Now, as for the pros and cons for this thing, it's the pros are they're cheap. You can buy around 50 of those. You can buy around 50 of those for under $2. They're reliable in the sense that they can last a long time. I have one in a project that's been running strong for the last 10 months or so. And they are perfect for hobbyists. I mean, they're small and they fit everywhere. They're breadboard friendly. The only thing that I find negative about them is that they're not reliable in the sense that you can put 3 or 4 of them and each one will give you different readings. They might differ a bit, not a lot, so they're not all accurate. probably the quality control leaves something to be desired. But in general, it's perfect for any project that you want to use it in, and I really like them and recommend them for everyone. So until next time, thank you for watching and stay safe.